According to the National Electrical Code, Article 250.24a states the grounding electrode conductor shall be connected to the equipment grounding bus or terminal within the grounding electrode system enclosure, or where such enclosure is provided with a grounding terminal for this purpose to this terminal. This code article requires the connection of the grounding electrode conductor, also known as the GEC, to the equipment grounding bus or terminal within the grounding electrode system enclosure. The purpose of this requirement is to ensure that the grounding electrode conductor is protected from physical damage and corrosion, and to provide a low impedance path to ground. Consider a scenario where a number 4 concrete encased electrode is connected to a lug outside the metal enclosure of the main disconnect. This would be a violation of the National Electrical Code, as the grounding electrode conductor must be connected within the grounding electrode system enclosure. Therefore, failing the inspection in such a case would be the correct decision. The opinion that the article does not preclude an exterior concrete encased electrode connection if all other service grounding is okay is incorrect. The National Electrical Code specifically requires the grounding electrode conductor to be connected within the grounding electrode system enclosure. In conclusion, the grounding electrode conductor must be connected to the equipment grounding bus or terminal within the grounding electrode system enclosure. Connecting the grounding electrode conductor to a lug outside the enclosure is a violation of the National Electrical Code and is not allowed. Let's delve further into the reasoning and implications of this requirement. The National Electrical Code is very specific about where the grounding electrode conductor should be connected to ensure the integrity and effectiveness of the grounding system. The grounding electrode system is designed to provide a path for fault current to return to the source, allowing overcurrent protective devices like circuit breakers or fuses to operate and clear the fault. A properly installed and connected grounding electrode conductor is crucial for this process. When the grounding electrode conductor is connected inside the grounding electrode system enclosure, it is protected from physical damage such as accidental impacts, exposure to weather, and other environmental factors that could compromise the connection. Corrosion is a major concern in electrical systems, especially in outdoor or damp environment. By keeping the connection inside the enclosure, it is shielded from moisture, chemicals, and other corrosive elements that could degrade the connection over time. A corroded connection can increase the impedance of the grounding path, reducing its effectiveness and increasing the risk of electrical shock or fire. The National Electrical Code aims to minimize the impedance of the grounding path to ensure that fault current can flow quickly and easily back to the source. This low impedance path helps to trip over current protective devices quickly, reducing the duration of the fault and minimizing damage to equipment. Connecting the grounding electrode conductor inside the enclosure helps to maintain this low impedance by providing a direct and secure connection to the grounding bus or terminal. Now let's explore some common scenarios where violations of this requirement might occur. One common mistake is connecting the grounding electrode conductor to a ground rod clamp or a water pipe clamp that is located outside the main service panel. While these connections might seem convenient, they do not meet the requirements of the National Electrical Code because they are not located within the grounding electrode system enclosure. Another potential issue is when an electrician runs the grounding electrode conductor through a hole in the enclosure and connects it to a lug on the outside. Even if the lug is bonded to the enclosure, this is still a violation because the connection itself is not located inside the enclosure. It's important to note that the National Electrical Code does allow for some flexibility in how the grounding electrode conductor is routed and connected, but it always requires the connection to be made inside the grounding electrode system enclosure. For example, if the enclosure is equipped with a grounding terminal specifically designed for connecting the grounding electrode conductor, then the conductor can be connected to that terminal. However, the terminal must be located inside the enclosure. Some electrical inspectors might argue that an external connection is acceptable if it is properly bonded and protected, but the National Electrical Code is very clear on this point. The grounding electrode conductor must be connected inside the enclosure, regardless of any other considerations. This requirement is in place to ensure the safety and reliability of the electrical system, and it should not be disregarded. To avoid violations, it is essential to carefully inspect the grounding electrode system and verify that the grounding electrode conductor is properly connected inside the enclosure. If there are any doubts or questions, it is always best to consult with a qualified electrical inspector or engineer. Understanding the specific requirements of the National Electrical Code is crucial for ensuring electrical safety and preventing potential hazards. The rules regarding grounding electrode conductor connections are a fundamental aspect of electrical installations, and it is the responsibility of all electrical professionals to adhere to them. The grounding electrode conductor is a critical component of the overall grounding system, and its proper installation and connection are essential for protecting people and property from electrical hazards. Therefore, strict adherence to the National Electrical Code requirements for grounding electrode conductor connections is paramount. Let's consider some additional factors that may influence the interpretation and application of this rule. The size and type of grounding electrode conductor required for a particular installation are determined by the size of the service entrance conductors. National Electrical Code Table 250.66 provides guidance on selecting the appropriate size of grounding electrode conductor based on the size of the service entrance conductors. It is essential to consult this table and ensure that the grounding electrode conductor is properly sized to handle the available fault current. The material of the grounding electrode conductor is also important. Copper and aluminum are the most common materials used for grounding electrode conductors, and each has its own advantages and disadvantages. Copper is a better conductor of electricity and is more resistant to corrosion, but it is also more expensive than aluminum. Aluminum is lighter and less expensive, but it is more susceptible to corrosion and may require special connectors to ensure a reliable connection. The grounding electrode system enclosure itself must also be properly grounded and bonded. This ensures that the enclosure is at the same potential as the grounding electrode conductor, which helps to prevent voltage differences that could create a shock hazard. The National Electrical Code requires that all metallic enclosures containing electrical equipment be grounded and bonded in accordance with specific rules. Furthermore, the grounding electrode conductor should be installed in a manner that protects it from physical damage. This may involve running the conductor through conduit or other protective measures. The goal is to ensure that the conductor remains intact and able to perform its function in the event of a fault. Now let's discuss some of the potential consequences of violating the grounding electrode conductor connection requirement. Improperly connected grounding electrode conductor can increase the risk of electrical shock, fire, and equipment damage. If a fault occurs in the electrical system, the fault current may not be able to flow back to the source quickly enough, which can cause the voltage to rise to dangerous levels. This can create a shock hazard for anyone who comes into contact with the faulty equipment or wiring. A poorly connected grounding electrode conductor can also increase the risk of fire. If the fault current is not able to flow back to the source quickly, it can cause the wiring to overheat and ignite nearby combustible materials. This can lead to a fire that can spread quickly and cause significant damage. Equipment damage is another potential consequence of a poorly connected grounding electrode conductor. If the fault current is not able to flow back to the source quickly, it can damage sensitive electronic equipment. This can result in costly repairs and downtime. In addition to the safety risks, violating the grounding electrode conductor connection requirements can also result in fines and penalties from electrical inspectors. Electrical inspectors are responsible for enforcing the National Electrical Code, and they have the authority to issue citations for violations. These citations can result in fines, and in some cases, they can even lead to the suspension of an electrician's license. Therefore, it is essential to comply with all National Electrical Code requirements for grounding electrode conductor connections to avoid these potential consequences. To summarize, the National Electrical Code requires that the grounding electrode conductor be connected to the equipment grounding bus or terminal within the grounding electrode system enclosure. This requirement is in place to ensure the safety and reliability of the electrical system, and it should not be disregarded. Violations of this requirement can increase the risk of electrical shock, fire, and equipment damage, and they can also result in fines and penalties from electrical inspectors. Therefore, it is essential to carefully inspect the grounding electrode system and verify that the grounding electrode conductor is properly connected inside the enclosure. If there are any doubts or questions, it is always best to consult with a qualified electrical inspector or engineer. The grounding electrode system is a fundamental aspect of electrical safety, and it is the responsibility of all electrical professionals to understand and adhere to the National Electrical Code requirements for grounding electrode conductor connections. Now let's consider some specific examples of how this requirement applies in different types of electrical installations. In a residential electrical service, the grounding electrode conductor is typically connected to a ground rod or a water pipe. The connection must be made inside the main service panel where the equipment grounding bus or terminal is located. The grounding electrode conductor should be sized according to National Electrical Code Table 250.66 based on the size of the service entrance conductors. In a commercial electrical service, the grounding electrode conductor may be connected to a ground ring, a concrete encased electrode, or a combination of grounding electrodes. The connection must still be made inside the main service panel or a separate grounding electrode system enclosure. In industrial facilities, the grounding electrode system may be more complex, involving multiple grounding electrodes and bonding connections. However, the basic principle remains the same. The grounding electrode conductor must be connected inside the grounding electrode system enclosure. Regardless of the type of electrical installation, it is essential to carefully inspect the grounding electrode system and verify that the grounding electrode conductor is properly connected. This should be done during the initial installation as well as during any subsequent modifications or repairs to the electrical system. Regular inspections can help to identify potential problems before they become serious safety hazards. In addition to the grounding electrode conductor, there are other important components of the grounding system that must be properly installed and maintained. These include the equipment grounding conductors, the bonding jumpers, and the ground fault protection system. The equipment grounding conductors are used to connect the metallic enclosures of electrical equipment to the grounding system. This helps to ensure that the enclosures are at the same potential as the grounding electrode conductor, which reduces the risk of electrical shock. The bonding jumpers are used to connect different parts of the grounding system together, such as the metal water pipe and the electrical service panel. This helps to create a low impedance path for fault current to flow back to the source. The ground fault protection system is designed to detect ground faults and quickly disconnect the power to the affected circuit. This helps to prevent electrical shock and fire. All of these components must be properly installed and maintained to ensure the safety and reliability of the electrical system. Now let's address some common misconceptions about grounding electrode conductor connections. One common misconception is that it is acceptable to connect the grounding electrode conductor to a metal water pipe outside the building. While this may have been acceptable in the past, it is no longer permitted by the National Electrical Code. The grounding electrode conductor must be connected inside the grounding electrode system enclosure. Another misconception is that it is not necessary to connect the grounding electrode conductor if the electrical system is already grounded to a ground rod. However, the National Electrical Code requires that all electrical services be grounded to a grounding electrode, regardless of whether or not they are also grounded to a ground rod. A third misconception is that it is acceptable to use a smaller size grounding electrode conductor than is required by National Electrical Code Table 250.66. However, the grounding electrode conductor must be sized according to this table to ensure that it is able to handle the available fault current. It is important to dispel these misconceptions and ensure that all electrical professionals are aware of the correct requirements for grounding electrode conductor connections. Proper grounding is essential for electrical safety, and it is the responsibility of all electrical professionals to adhere to the National Electrical Code requirements. In conclusion, the National Electrical Code requires that the grounding electrode conductor be connected to the equipment grounding bus or terminal within the grounding electrode system enclosure. This requirement is in place to ensure the safety and reliability of the electrical system, and it should not be disregarded. Violations of this requirement can increase the risk of electrical shock, fire, and equipment damage, and they can also result in fines and penalties from electrical inspectors. Therefore, it is essential to carefully inspect the grounding electrode system and verify that the grounding electrode conductor is properly connected inside the enclosure. If there are any doubts or questions, it is always best to consult with a qualified electrical inspector or engineer. By following these guidelines, electrical professionals can help to ensure the safety of people and property from electrical hazards.